In this slide, we want to examine the columns U0, U1 until UN minus 1, the columns of WH. Remember that the elements of the WH matrix is e to the power j 2 pi over n kn. As we fill up the matrix, as we are moving along the different rows, we are changing little n with k fixed. And in this example, k is equals to 1 first, and n is equals to 8, and then we fill up the elements. I fill up the elements in the polar notation. So e j 2 pi over 8 for capital N, k is 1, and little n, it goes from 0 to 7. So n equals to 0, n equals to 1, small n until 7. Why 0.25 pi? Is because pi over 4, so it's 0.25 pi. Little k is 1, so I drop the notation. So this is the column what? Column 1. We are going to start with index 0, so column 1 of the W8 matrix. The capital N here as 8 shows that this is a 8 by 8 matrix. Alright, now let's examine for k equals to 2. In k equals to 2, the only thing changed is that we are going to change this notation here for k equals to 2. The rest is the same. So it's 4 pi divided by 8 is 0.5 pi. So the first element is 0.5 pi. Here is n equals to 0, n equals to 1, n equals to 2 until small n equals to 7. Now you can check this guy and this guy, the inner product will be 0. So they are orthogonal. Now let's visualize this guy. When we are multiplying 1e 0.25 pi times 0, so this is angle 0. So it is absolute value 1 angle 0. Here is absolute value 1 angle 0.25 pi. Here's absolute value 1 angle. Here is 0.25 pi times 2 is 0.5 pi. So let's visualize this. This is the first element along the rail, which is 1 angle 0. So if we view this as a vector of magnitude 1, and the angle making across the real axis anti-clockwise is 0 degrees. 1 angle pi by 4, because here the angle is pi by 4, and the radius is 1. So it's 1 with an angle of pi by 4. The next guy, 1 angle pi by 2, because actually it is parallel to this imaginary axis. But remember, this is a complex exponential rotating, and he's rotating anti-clockwise, and this is time coming out here. Okay, so now we can view the first column of WH. It is a complex exponential rotating, and in 8 samples he will repeat, and he'll go back to the same point, 1 angle 0. So this is a 3D visualization, this is a 2D. So let's see the 2D visualization. This is the first element, going to the second element, going to the third element, and each time he's moving by pi by 4. Okay, so this is the first column. In the second column, what happened? When we visualize this again, first element, second element. Every time he moves by one sample, he's moving by pi by 2. So you see that actually in the 3D, he'll move 2 rounds using n sample. So the k equals to 2 means how many cycles, what is the harmonics with respect to the fundamental frequency, how many cycles he's rotating per n sample. K equals to 3, he rotate even faster. With 8 samples, he rotate 3 rounds. Okay, so with that, we now begin to understand what are the columns of WH. In the next slide, we'll study the DFT matrix columns properly. Thank you.